today's talk, which is by Lavinia Picollo from the University College London. First, before I forget, I should thank our sponsors. So we receive support from three institutions: the University of Waikato and the University of Alabama, and also from the Yukon Humanities Institute. They host the Future of Truth project, and we receive some support from them as well. Now, today's talk, the title is The Unity of Logical Consequence, and I believe that you've all had a chance to look at the abstract, which has been circulated multiple times on various mailing lists by the very energetic Drew Johnson. I believe that he's also put a Dropbox link in the chat to the handout. Yeah, or if not yet, it's coming. Today, the format will be 45 minutes for the presentation, and then afterwards we'll have 45 minutes for Q&A. So please, Lavinia, go ahead.
Thank you. Thank you very much for inviting me to give this talk. I'm desperate for comments, as I said before, so I'm really, really excited about this. This talk is about the unity of logical consequence, so you can imagine what I'm going to say, but let me give you a quick introduction first. So what I'm going to say now is something similar to the state of nature of Hobbes and Locke and Rousseau and so on. You know, it's like a fictitious historical reconstruction of events regarding the notion of logical consequence. I know this is probably, I'm very ignorant about the proper history of logical consequence, and I don't want to make any false claims, but I think more or less it went like this, and I think it's permissible to think about it this way. So at some point before we had any kind of formal language, we had this informal notion in mind, more or less, which says that an argument, of course, in natural language, because this is the only language we have, from a set of sentences to a sentence is logically valid, just in case the conclusion follows from the set of premises, exclusively in virtue of the meanings of logical terms that occur in the premises and conclusion, right? And of course, this notion is not pre-theoretic, because there's a lot of theorizing involved already in the formulation of the view. But it's imprecise in the sense that we don't know yet what the logical terms of a language are, what their meanings are, and how to explicitly articulate them. And finally, we still don't know exactly how to understand that follows from in virtue of meaning, right? So if we want to give a precise, a formal or precise account of logical consequence based on this informal notion, what we need to do is basically decide those three things, provide accounts of those three things. And this is basically what happened, right? At some point, we got this semantic approach very early on, actually. So, for instance, Bolzano, but like I think we can find traces of this early on, which is roughly saying the following. Okay, the meaning of the logical constants is going to be articulated by semantic clauses, namely by clauses that state the truth conditions, the conditions under which sentences that contain those symbols, the logical constants as their main symbol, are true and false. And logical consequence is to be understood as truth preservation from premises to conclusion in every possible variation of the meaning of the other terms, right? So using these things to fix the meaning of the logical terms, all the rest can vary. I think this is, it's like a common core of the semantic approach to logical consequence. And then the syntactic approach also emerged, basically because the idea of truth was not very appealing for people back then. So they developed a syntactic approach instead, in which the meaning of the logical terms is rather articulated by rules of inference that are meant to encapsulate the correct use of the logical terms. And logical consequence, again, is cashed out in terms of the availability of proofs, namely sequences, chains of inferences that start from the premises and take us to their conclusion. Note that I didn't say anything about what the logical terms of a language or our language are, and I'm going to ignore this question because I think you can just adapt everything I'm going to say to whatever choice of logical terms you want to make. So I'm not going to talk about that. These two approaches of logical consequence are widely, I think, believed to be different conceptually, far away from each other, independent, and sometimes contenders, right? Like this one is, some people claim that one of them is more fundamental than the other, and so on. The goal of my talk is to show that this is not okay, not correct. This is not the right way of thinking about this, that actually there's a very close conceptual connection between the two approaches, modulo a deflationary account of truth. Of course, you can think, of course, there's a conceptual link in a way, because we have soundness and completeness, for instance, in many cases, and obviously these two things are tracking the same notions. And I mean, if I want to be super daring, I would say they're the same thing expressed in different ways, but not only extensionally, but intentionally. But I don't want to say that. I think that's maybe going too far. But it's closer to that than to mere extensionality or extensional equivalence, sorry. To show this, I need to use a formal, I'm going to formalize things a little bit, but this formalization is not the real deal. This is just for clarity. The real deal is natural language, right? The project is to give a notion of logical consequence, a precise formal notion of logical consequence for natural language, right? And this is given in natural language because we don't have formal languages before we start coming up with all these things, right? So L plus is going to be basically a toy representation of our natural language, our meta language. We understand our language. We're giving definitions of terms in our language. This is the language we speak. And when we prove things in this language, we prove the things informally. Of course, we prove things informally because we haven't developed a proof system yet before we embark in this enterprise. So L plus is going to be our meta language. And I'm going to assume that it's governed by classical logic. And this assumption is not essential, but I need to make some assumptions just to not get too distracted by other things. And I'm going to assume that we're trying, the language for which we're going to try to define logical consequence is either this verism language, right? For instance, in English, we try to define what arguments are valid in English, or maybe a fragment of it, depending on whether we encounter certain difficulties or not. I'm going to assume that L plus contains some syntax and can talk about semantic concepts and so on, and prove semantic things about our object language L, which is the language for which we define logical consequence. So I'm going to assume it contains names for the expressions of L and some set theoretic vocabulary. Nothing depends too much on this, really. And now, to reduce the scope, I'm going to assume that the logical terms of L are negation, conjunction, and universal quantifier. Again, this is just a choice, it's not necessary. I'm also going to assume that L has some individual variables, individual constants, and predicates of different arities, and I'm going to leave out the identity symbol and function symbols for simplicity. Okay. Now, this is how the semantic account looks like from this perspective. For the semantic account, our meta language, the language in which we give the account, needs to have a truth predicate, right? Because we're defining validity in terms of truth preservation. And I'm going to assume that this truth predicate, which shouldn't be in italics there, is not definable in L. So in particular, L doesn't contain this predicate, and L also doesn't contain the resources to define this predicate. And then I'm also going to assume that, at least implicitly, this predicate is governed in our language, but by at least by every instance of the T schema for each sentence phi of the object language. So this is a minimal assumption, right? It could be that it's governed by many other things. I'm not assuming any form of deflationism yet. Then, how can we articulate? So the first step was to identify the logical terms, and so we did. This is an arbitrary choice, I know. The second step is to articulate the meanings of these logical terms in terms of truth conditions. And this is more or less how they will look like, right? for every, that means every sentence of the language, we say that a negation is true. The negation of that sentence is true, just in case the sentence is not true, right? I know this negation is not the same as that one. Like this is a syntactic function that basically, when it receives a sentence and it returns the negation of that sentence, whereas this one is not a function, it's just a connective. But I thought writing like under dots, dots under each of these symbols was going to be super cumbersome, and I would rather avoid it, but I can restore it and I can tell you where they go if you want to know later. And the same for conjunction, of course. Given two sentences, the conjunction of them is true, just in case each conjunct is true. And for the universal quantifier, for instance, we can give this condition. Given a formula and a variable free in that formula, the universally quantified expression that results from that is true, just in case every instance of it is true, right? And then finally, one can define substitutional validity as follows. One can say, well, an argument is valid just in case truth is preserved from premises to conclusion in every permissible variation, as we said, of the non-logical vocabulary, namely in every uniform substitution of each non-logical term with another expression of the same grammatical category. And this was like the first notion of semantic validity that appeared among logicians and philosophers. And it has three problems that are very well known. I think I'm not going to spend too much time on this because I think they're well known, but we can discuss them later. One of them is the unavailability of names. Not everything can have a name in a simple language like the ones we speak, right? So how are we, this clause for the universal quantifier is kind of wrong, because the fact that everything has a name, everything that has a name satisfies formula doesn't mean that everything in the universe, including those things that don't have names, satisfy the formula. Another problem that Edgemendi talks a lot about in his logical consequence book is the problem of the violation of persistence. So this means basically, if the language we are defining validity for doesn't have enough substitution instances, for instance, doesn't have enough predicates, imagine it only has one predicate and one individual constant, P and C, then this could turn out to be a logical truth, because I don't have any predicates to replace P with or C with, so that I obtain a false claim. And finally, if I can express the cardinality of the universe, then that sentence that expresses the cardinality of the universe will turn out to be logically true, and the ones that express that say that the universe has a certain cardinality and are false are going to turn out to be logically false. And this is not ideal, right? So Tarski proposed the model, Tarski and Vaught proposed the model theoretic version of validity instead, replaced this traditional substitutional account with a model theoretic one, which uses a satisfaction predicate, assignments, and they define validity in terms of models instead of substitutions, right? So the definition goes more or less as follows. Of course, you know this, but I want to pay attention to the certain details. An argument is valid if and only if truth is preserved from premises to conclusion in every permissible variation, not of the linguistic items involved in the argument themselves, but their meanings. So I just vary the meanings directly instead of, because then I don't depend on the linguistic items that I have in the vocabulary I have in my language, right? Actually, not true. It's not that I variate and I go through all possible meanings. I go through all possible extensions of meanings. This is what model theory does, right? Of the non-logical vocabulary. So basically, truth is preserved in every model. This would be the idea. The original intuition, the informal notion was about truth preservation under every possible variation of the meaning of the non-logical terms. And now I'm not considering all possible meanings, just all possible extensions, which are fewer than all possible meanings. That means that the model theoretic account, despite what most people think about it, is not the obvious account, the obviously correct account. It does have some artifacts. Here are some others that, of course, you already know about. One of them is that actually not even all extensions are available, right? Because, for instance, the extension corresponding to our predicate is a set is not available in model theory. And this is why we need Kreisel's squeezing argument to show that the model theoretic notion is actually an adequate notion to define logical validity. So it's not, I know this is the most widely accepted notion of logical validity and is taken as the notion of logical validity, but it doesn't fit the informal notion as well as we might think. And actually, this is why we use Kreisel's argument. And another very important issue is that if our object language, the fragment maybe of a language or for which we are defining logical validity contains set theoretical vocabulary, and of course we kind of want this, we don't want to exclude this possibility, logical truth doesn't entail truth, according to the model theoretic definition, right? Because for logical truth logical truth means true in every possible interpretation or every assignment of extensions to our words, but the appropriate extensions are not available if we are talking about sets, for instance, in a language. So we don't have basically truth in the standard interpretation, and therefore we might have truth in every interpretation, yet in every model, and yet not truth simpliciter. So I would like to suggest, let's go back to the substitutional approach and let's fix the problems that it had. And to do that, what I'm going to do is consider possible expansions of the language. So to avoid the problem of persistence, of the availability of names, and of the fixed cardinalities of the universe, I propose that we consider different possible expansions of our language, or object language L. So this means basically L prime is an expansion of L without adding dangerous semantic terms. So semantic-free expansion. And then we can just reformulate our semantic clauses to give truth conditions, not only for sentences in our actual language, but also for sentences in our potential languages, right? One of the important things is that our current language, the one we speak now, is a language we understand. It's just a fragment of our meta language, right? Before formal languages are invented, we just care about giving a definition of logical validity for our language. So we also understand the object language. And by an expansion of our object language, what I mean is the addition of a new term with the intention of, with the meaning, right? I just don't mean a vacuous expansion of the language with a new constant that doesn't mean anything. I mean, oh, I found a new object, I want to name it, right? And I add a new, for instance, constant to my language to name that object. So the expansions of the language are not just syntactic, but also they have, every new symbol will have a meaning as well. Now, this quotation won't be available in our meta language for every expression of, for every expression of a potential languages, for every expansion of L. But every time we expand our language, since the symbols that we add come with a meaning, we can extend the T schema correspondingly to be able to use the truth predicate for the new expressions, right? And this is because I want to understand the T schema and similar schemata dynamically or in an open-ended way, just like, for instance, Hartree-Field indicates in this footnote, in this quote, sorry. Typically, when we advocate a schema such as T schema or such as the law of excluded middle, we are not merely advocating the collection of instances that happen to be instantiated in our language. We are expressing a commitment to continue to accept new instances as we expand the language. And I think this is true about the T schema. Of course, in English, we expand English constantly, right? For instance, COVID is a new term, right? And of course, sentences such as COVID is dangerous now can be true or false, right? This is exactly how how the T-schema works in English, I believe. Okay, using these clauses, we can very easily define what a substitution is. A substitution is going to do the replacement of all the terms that are non-logical, and it's going to draw expressions to replace from any possible non-semantic expansion of the object language. So a substitution over an expansion of my object language is going to be a function that maps expressions of my, not every expression, but like every formula of my object language to the new language by respecting the syntactic categories, right? So constants, for instance, each constant C will be mapped to another constant C prime, could be mapped to a term, but remember, we don't have function symbols in the language for simplicity. So, quantifier, I need a quantified free formula that doesn't contain constants denoting things that are not in the set of things that satisfy this formula. To relativize all my quantifiers to this formula, so I'm going to allow quantifiers to be relativized, right? This is basically like assigning domains to, so when I can reinterpret, I can consider, basically, if I say, for instance, everyone came, I could consider a variation of meaning of that sentence as everyone in the philosophy department, every student. I could just consider a variation of the meaning of the universal quantifier is not exactly that, what I mean, right? But like variation of domains this way. And finally, predicates of arity n can be substituted with, can be assigned formally with n many distinct variables free. And a substitution simply maps each formula of my object language L to another formula of the expansion of this language by performing the appropriate replacements. So for instance, this formula from my belonging to my object language L will be mapped to, here I relativize this quantifier to the new expression, and I replace P with phi in both cases and C with C prime. This is the substitution, right? And substitutional validity can simply be defined as, I'm going to write this for my notion of substitutional validity, can simply be defined as truth preservation under every substitution from premises to conclusion, right? And now all the other problems are avoided. All the problems, cardinality, persistence, and the unavailability of names are solved. There are a few more upshots. The first one is that now we have logical validity entailing, logical truth entailing truth. This is the most important thing, because note that one of the substitutions is simply the substitution that substitutes every non-logical term with itself. And since I have truth preservation in every substitution, or truth in every substitution, I also have truth in that substitution, but so logical truth entails truth. And moreover, this is important, truth entails just the sentence itself. So I will have something like, if phi is a logical truth, then phi. And I will also have, if phi is a logical truth, then true phi. So Halbach, for instance, also adopts a substitutional approach to have, if phi is a logical truth, then phi is true, but he cannot go from there to phi, which I find pointless somehow. I want to be able to assert, right, logical truths. Okay, so this is my favorite version of my favorite way of cashing out, of precisifying the informal notion using a semantic road. And for the syntactic account, I'm just going to follow Tammet. He says here, we no longer explain the sense of a statement by stipulating its truth value in terms of the truth values of its constituents, namely using truth-conditional semantics, but by stipulating when it may be asserted in terms of the conditions under which its constituents may be asserted. The justification for this change is that this is how, in fact, we learn to use these statements. So this is a contender view, right, that says, well, now actually, what about, this is exactly how we learn about these things. So the meaning must be encapsulated, must be possible to articulate the meaning explicitly by giving rules of use. So here, standard rules of use for the terms that we have. A very important thing to note is that these rules are all schematic, in the sense that each of them captures infinitely many correct inferences of the same form in our calculus. And because they're schematic, I think we should also treat them in a dynamic way. We should also understand them dynamically. And this is because when we expand the language, for instance, we add a new term, COVID, we still want to infer things using the word COVID. I think this is all very natural. It makes a lot of sense. Validity is cashed out in terms of the availability of proofs, as I said. So what is a proof? Well, a proof is, this is a little bit tricky what I wrote here, but basically, well, a finite sequence, right? Each member is either a premise or follows from one of the rules, or follows in this way, and this is how I have that rule there, the introduction of the universal quantifier. So this is very important actually for the technical details later, but I will only get into that if you care about it and at Q&A. So basically, this is a way of formulating the rule of introduction of the universal quantifier. And then we can define syntactic validity as the availability of proofs. Now that we know exactly what a proof is in very precise terms. These two approaches, yes, they satisfy soundness and completeness, which means that they're extensionally equivalent. You can prove this, even noting that I substituted the mole theoretical account with a substitutional account, and soundness and completeness still hold, so everything's fine. But then we have the conceptual difference, right? For instance, Shapiro writes the following: to these two notions answer to different intuitive notions of consequence. Is one of them primary and the other secondary? Or perhaps they are autonomous and independent. Maybe there are two distinct notions of correct reasoning, valid thought, or inference. And this is exactly what I want to argue. No. They respond to the same informal notion. And if we look at what deflationism is telling us about truth and the truth predicate, we can see that they're not autonomous and independent or distinct notions of correct reasoning. They're exactly the same thing, roughly, modulo truth. So to argue for that, let me, how long do I have? Oh, that's good. Let me say something very brief about deflationism. I think most people here are experts, so I don't have to say much. I'm just maybe tell you how I conceive of it. I'm trying to follow Quantifier and Horridge here mainly. I think deflationism has a linguistic and a functional aspect. The linguistic aspect is basically that truth is essentially disquotational, that the T schema or T rules, if you wish, it doesn't have to be in classical logic. Since I'm using classical logic, the T schema and the T rules are the same thing. T rules, I mean introduction elimination rules for the truth predicate. Just these things suffice to fix the meaning of the truth predicate. There is nothing that needs to be added on top of this to fix the meaning of the truth predicate. So this minimal assumption I had at the beginning that when I give a semantic account of logical consequence, I need a truth predicate, and I was assuming it satisfies the T schema. Now I'm saying deflationism is saying and only that, in the sense that everything else follows logically from the T schema. Every other meaning postulate, so to speak, for truth. And the functional aspect is that the truth predicate only plays a sort of expressive or logical role in the language. Of course, I'm not thinking about every possible context, only theoretical and idealized context. It could be that there's a community that uses the truth predicate in a weird way. The most important bits of this role, the most important aspect of this role is its generalizing capacity. So the truth predicate, because it's disquotational, allows us to generalize sentence position. Basically, it allows us to have sentential quantification in a first order setting. So imagine I want to assert that for each sentence phi, if phi is a theorem of arithmetic, then phi. I can do that using a sentential quantifier, right? Quantifying both inside these corner quotes here and here. But as you know, in natural language, at least in English, this is kind of ungrammatical. So we don't have this available, these sentential quantifiers really, unless you think that truth is providing those. So the alternative is to say, well, no, just say that all theorems of arithmetic are true. And that has the same effect, so to speak. So this is one of the main thesis of deflationism, that there is a very close connection between 1 and 2. Of course, 2 entails 1 by disquotation and the meaning of the universal quantifier, but there's something more than that. Many things entail 1. And I think 2, and this is when I say, well, this is something I don't want to get too much into, but I think in a way 2 says the same as all the instances of 1, provided that we understand 1 in an open-ended way. However, from a formal point of view, 2 is a bit stronger, right? So I don't want to say that they say exactly the same. But another way of thinking about this is that 2 finally express somehow all the instances of 1. Some other people have said that deflationism is committed to the idea that truth has no explanatory role in our theorizing. I don't think that's really part of deflationism, at least, for instance, Field doesn't believe that, and I very much sympathize with this quote by Field. Any use of true in explanations which derives solely from its role as a device of generalization should be perfectly acceptable. I do believe this. So if it figures in an explanation, it has to be performing its generalizing role or one of its logical roles, one of the roles that deflationism identifies, roles of truth predicate. Now, before I get into the main argument of the talk, I need to say a bit about the invisibility thesis. This is the thesis that deflationism is incompatible with truth-conditional semantics, understood in a Davidsonian or model theoretic way, both. So basically, a lot of people think deflationism is compatible only with inferentialism. You cannot use truth conditions to explain the meanings of logical connectives. And here are the most salient arguments and my responses to them. So first I need to lay the ground to show you that deflationism is compatible with the substitutional approach. Before I tell you how deflationism can help us see the substitutional approach and the syntactic approach as 2 sides of the same coin. The first argument is, well, look, the semantic clauses are meaning postulates for the truth predicate typically. And deflationism says that the only meaning postulates are the T-schema and those that follow logically from them, from the T-schema. How is this possible? And the second argument, which is very similar, I'm going to put them together so I give a unified response, is that the semantic clauses cannot both fix the meaning of the truth predicate and at the same time the meaning of the logical connectives on pain of indeterminacy. These are very famous arguments, both of them. My answer is very simple. Actually, everything I said is compatible with the meaning of the truth predicate just being fixed by the T-schema. Remember, this was my minimal assumption. So what are the semantic clauses that I gave? Well, there, I was not thinking of the semantic clauses as principles that were articulating the meaning of the truth predicate. I was using the truth predicate there to articulate the meaning of the logical terms. These are not meaning postulates for the truth predicate. They're meaning postulates for the logical terms. Of course, I need to articulate the meaning using sentences. I need to use other expressions. One of those other expressions happens to be the truth predicate. I'm using the truth predicate rather than introducing them in these semantic clauses that I gave. Okay, here are 2 more arguments. Understanding the meaning of true via T-schema presupposes a prior grasp of the meaning of every sentence of our language. How so? So this is Dummett. This is a bit like, well, very Dummety. An explanation that T-phi cannot explain the sense of, an explanation that if I want to explain, if I'm explaining that T-phi, that cannot explain the sense of phi, because to understand T-phi, I need to point at the T-schema if I'm a deflationist. And to understand that instance of the T-schema, I need to understand phi, because phi is part of that instance of the T-schema. This is the argument. And then another very much related argument is by Burgess. To formulate the T-schema, one needs to know which expressions are truth apt. But to know which expressions are truth apt, I need to know which expressions are true. And therefore, I just cannot give an explanation like this. Okay. I think this is, there's a very easy way to see if we accept this reasoning, then we end up rejecting the use of schemas to give meaning for the logical connectives in general. So we end up rejecting inferentialism in general and much more, which seems a bit absurd. We know that we cannot do without some form of rule of schema because of Quine, right? point of views on conventionalism, basically. So I think this has very bad consequences if we accept this line of reasoning. Note that what would happen is the following. So for instance, we could reason as follows. No logical term introduced by inference rules can feature in explanations of the meanings of other terms, or at least of the truth predicates. So for instance, an explanation that phi if and only if psi cannot explain the sense of phi anymore. Note that we do want to do that a lot. Sometimes we want to say, well, to be F is to be G, and sometimes we use a biconditional for that, right? So a biconditional expression is the typical kind of expression we want to use to explain the meaning of one of the sides of that biconditional, right? But we cannot do it because to understand the biconditional, we might be using rules of inference that are schematic. And to understand that particular biconditional, I need to understand both sides beforehand, so I couldn't use it, period. That's horrible. Similarly, to formulate a rule of inference or a semantic clause for the biconditional, one needs to know which expressions are truth apt, right? So I need to know truth before I know all of this. I think this is not correct, right? Of course, we need to know which sentences are declarative to see what instances of inference rules I'm going to accept, but that doesn't mean I already need to have a full grasp of the notion of truth before I do this. I think this is the what's going on here. Schematic principles and rules provide just a holistic explanation of the meaning that doesn't have to be viciously circular. This is perfectly correct. This is how we do introduce meaning in many cases. It's not possible to introduce the meaning of absolutely everything using just quantified principles because of what Quine said. So if this line of reasoning were right, we would end up not knowing the meaning or not being able to articulate the meaning of anything. Okay, and finally, and most importantly, maybe, since the semantic clauses are explanatory of the meaning of the logical terms and the truth predicate features in them, then the truth predicate is having an explanatory role, but that's not very deflationist. As I said, I'm with Field, and I think that as long as the truth predicate is playing its generalizing role in these clauses, everything is fine. And this is what I'm going to argue for in the next section. I'm going to show you that in those semantic clauses, what the truth predicate is doing is not explanatory, it's just playing its deflationist generalizing role. Heck disagrees. Heck says. So this is the Heck challenge. What we need to ask is whether deflationism provides us with resources to unmask the use of truth in semantics as purely expressive. So is it purely expressive? To put it differently, the question is whether deflationism is consistent with taking semantics seriously. And I'll show yes, of course, because of the following. Actually, my main thesis. The truth predicate deployed in the semantic clauses is allowing us to generalize. In particular, it's allowing us to finitely express the semantic rules of inference of our calculus. So the semantic clauses can be seen as finite ways of expressing the rules of inference of the calculus, just as much as 2 is a way of finally expressing all instances of 1. Because the rules of our calculus are schemata just as much as 1. How can I show that? Well, if you were to formulate the rules of our calculus, when you tell them to your students, for instance, what does the rule says? What does the rule for negation, the first rule for negation say? Where is it? Here. Well, let's focus on this one. It's a bit simpler. What does it say? Well, it says that if you have phi and not phi, what do you mean you have? Well, if phi, for any two sentences, if phi, and for any sentence, phi, if phi is true and not phi is true, then psi is true for every psi. This is sometimes how we we read out these rules. And I think the truth predicate there is just, yeah, allowing us to do this in a finitary way. So this is my suggestion. My suggestion is this one. expresses the rule of introduction of negation. This one expresses the rule I just read. It says, in every expansion of a language, and then if you have any two sentences of that expansion, X and Y, if X and not X are true, then Y is true. I think this is a good way of expressing that rule using a truth predicate, and a more meta-linguistic, if you wish, way, in a finitary way. It's a way of formalizing, finally expressing the schema that is the rule of elimination of negation. And similarly for the others that we can go through if you want Q&A. In general, I would say one can finally express a rule with the aid of the truth predicate and syntactic vocabulary to capture the structure of the schema, right? To say, if a conjunction is true, then we say that one of the premises is a conjunction, then the first conjunct is true, and so on. This for every connective. We also have conjunction in the meta language to conjoin the premises. Why can we use conjunction in the meta language to conjoin the premises? Well, because apparently repetitions and order don't matter for the premises, and so the conjunction is perfect to conjoin them. If you prefer a non-classical logic in which this is not the case, you'll use something else, of course. And the conditional is good to express the passage from premises to conclusion. Why? Because it detaches and satisfies deduction. If it didn't, then you would have to have another connective there to connect the premises to the conclusion. And finally, the universal quantifier allows us to generalize the schema because it entails its instances, and basically it entails the instances, and in a way, nothing else, right? This is the close connection between 1 and 2 in the example of all theorems of arithmetic. It's not something that just entails all the instances, but also kind of nothing else, right? They're kind of the same thing. And actually one can show that the equivalences between each of the semantic clauses, the semantic clause for negation, the semantic clause for conjunction, and the semantic clause for the universal quantifier that I gave in the substitutional approach, and the finite expressions of the rules using a truth predicate in each case. One can show that these are mutually entailed without using them, using minimal resources, namely the T-schema and intuitive logical principles. So principles that are implicit in our use of the truth predicates in our language, and principles that are implicit in our use of logical vocabulary in our meta language, if provided that our meta language is classical, as I might see. Okay, have no time, but I'm almost there. Now, here's a proof of how one direction of the semantic clause for negation, namely this one, that if something is false, then it's not true, right? That a negation is true if this formula without the sentence without the negation is not true, right? This is one of the directions of the semantic clause that follows exclusively by the rule that I read out, the one that is basically ex falso. How so? Well, basically, if you assume this and that, right, for contradiction, if you assume that we have both X is false and X is true, by this formulation, this finite formulation of the rule, which we have here, we can conclude the truth of everything. In particular, I can conclude that that horrible contradiction is true, provided that it exists in my language. Eventually, I will add the identity predicate, so I know I will have contradictions in my language or false sentences in my language. By the T-schema, I know that this is the case, right? From this follows. But I know also, in my meta language, I know that it's not the case that PC and not PC for any atomic, at least, short expression, PC. Therefore, I can conclude that this is not the case, and I get a contradiction. So after all, it was not possible to have these two things at the same time, which gives me my principle. Now, what happened then to Carnap's categoricity problem? I'm kind of like bypassing it completely. I'm showing how I can conclude the problematic direction of the semantic clause for negation, namely that if something is false, then it's not true, from the corresponding rule, inference rule for negation, which is what Carnap says you cannot do, right? It just simply, you cannot exclude the possibility that every sentence is true. So you cannot conclude from the fact that something is false that is not true. How did you do it? Well, because it turns out, like, as I said at the beginning, I am not working in a formal, unknown, meaningless language. I'm working in our language and in a language we understand. And I already know that some sentences are not true. I can just, like, I don't know, observe, oh, snow is not black. Great, so I know that it's not true that snow is black. Simple as that. I can use that one to show that X falso gives me that not every sentence, that if a sentence is false, then it cannot be true. It's just as simple as that. Of course, Carnap's categorizing problem only emerges for languages that we don't really understand. Okay, so let me tell you what I did. So I'm going to stop here at 3 and then you can take a look at the rest. Okay, I think I showed that from a deflationary perspective, using a predicate that satisfies the G schema and only that, the semantic clauses are just finite ways of expressing the rules of inference. And why did I show that? Because according to deflationism, the truth predicate couldn't be doing anything else. And I just showed you that the semantic clauses are implied by, mutually implied by those finite ways of expressing the rules of inference. So basically the semantic clauses are equivalent to those finite ways of expressing the rules of inference, modulo the T schema only and basic logical principles. So I showed that those two things are doing the same, and obviously deflationists will believe that the principles that I gave that finally express the rules of inference do finally express the rules of inference and nothing else. And this has 3 very important consequences, in my opinion. The first one is that the truth predicate involved in the semantic clauses is actually not playing a substantive role, as many have argued, is just playing the role of allowing us to finally express the rules of inference, maybe in a more concise way. And in as much as the rules of inference encapsulate the meaning of the logical terms, if a deflationist believes, oh, the rules of inference encapsulate the meaning, therefore, if that's the case, the finite expressions of those rules using a truth predicate also encapsulate the meanings, and therefore the semantic clauses also encapsulate the meanings. So the deflationist can say the semantic clauses encapsulate the meanings of the logical terms just as much as anybody else. And finally, that there is a conceptual link between, a very close one, between the semantic understood substitutionally approach and the syntactic approach to validity. Not only because the way they articulate the meaning of the logical terms are basically the same thing, modulo deflationary truth, but also because both guarantee a path from the premises or truth of the premises, which is the same for deflationists, to the conclusion or the truth of the conclusion of a valid argument, such that each step is licensed exclusively by a principle that articulates the meaning of the logical terms. Okay, thank you very much.